I'm going to be talking about UNC 4899, North Korean threat actor that's been conducting highly targeted campaigns against developers and crypto infrastructure. This group operated under multiple aliases, including Slow Pisces and Trader. And their latest campaign was based entirely around social engineering and DevOps compromise. So here's how they did it. Threat actors posed as recruiters on LinkedIn and Telegram, reaching out to developers with fake freelance job offers. Once trust was built, they'd send a quote unquote skills test, which was actually a malicious Docker container disguised as a coding challenge. Victims who executed the container unknowingly granted that attackers access to internal systems and cloud environments. From there, the threat actor had a foothold to pivot into infrastructure, harvest credentials, and target assets, particularly those related to crypto. Their goal wasn't just initial access, it was to silently embed into the cloud supply chain and extract anything of value, especially private keys and crypto wallet access. Sorry. At least two organizations were confirmed to be compromised. Those specifics on damage remain undisclosed. And as of now, there are no arrests, no takedowns, and no recovery of stolen data. The actors are still operating. I believe this story is not just a headline, but it's a blueprint for how modern threat actors are bypassing conventional security by using trusted platforms like Docker and abusing professional networks like LinkedIn and delivering payloads through containers rather than executables. They evade endpoint detection, trick analysts, and stay persistent. It's a reminder that our trust in common tools can become our weakest link. As future defenders, we all need to recognize this evolution and understand that people, not just systems, are still the front line. Thank you all for listening. We'll be moving on to the next story.
Good evening, everyone. My name is Riyad, and today I'm going to walk you guys through a multi-layer redirect phishing campaign targeting Microsoft 365 users. So, security researchers recently discovered that attackers leveraged legitimate link wrapping services like Proofpoint and Intermedia to cloak malicious destinations. And normally, these services wrap outbound links sent from corporate email accounts so that the destination can be scanned in click time. However, threat actors have found a way to abuse that trust. So, in the campaigns monitored over the past 2 months, attackers first shortened their phishing URLs to bit.ly. Then they sent those shortened links from accounts inside organizations that already use Proofpoint or Intermedia. And as a result, the URLs ended up double wrapping using bit.ly, and then the link defense service creating a multi-layer redirect chain. And this chain effectively bypassed email filters since the destination wasn't flagged by the time the link was clicked. So recipients clicked links thinking that they were safe because they saw the defender domain, and in fact, Proofpoint's URI defense or Intermedia's wrapping URL appeared. But the final landing page was a fake Microsoft 365 login site designed to capture credentials. And the phishing emails use plausible context, voicemail notifications, team document shares, or unread message prompts, luring users to click without suspicion. So, pretty much, this tactic is very dangerous because it hides the malicious destination behind trusted infrastructure, making detection really difficult. So, what can we do about this dangerous tactic? So, first, we can monitor and block excessive redirect chains, especially those involving known wrappers like urldefense.proofpoint.com and url.emailprotection domains. Secondly, we can enforce link scanning at click time and enable preview features so you can inspect the ultimate URL before redirection. And finally, educate users to hover over links and verify final destinations and escalate any phishing themed messages to your security team. That's it for me, and we'll move on to the next presentation. Thanks.
Yeah, hello everybody. I'm Vishnu. So for this news segment, it was actually posted in the general chat for the infosec the infosec general chat in the ISSessions Discord, and it caught my attention because like I actually work at like a public library and it kind of deal with stuff like paper cut. So it's a company that provides like print management software, and it's primarily in like a lot of institutions or places with like public libraries and such, mainly for like things like paid printing. And Sheridan is actually one of the organizations that has the system in place in order to like print documents and such. And so, like the CISA, they identified a vulnerability involving cross-site request forgery. So that's when like a threat actor makes a user perform like an action they didn't intend to through like a web application security vulnerability and through like the help of social engineering. So it's done while the victim is authenticated into a website and the threat actor is launching like a forged request onto it. And in this case, like the flaw can also allow like an administrative user into being tricked as a form of social engineering into clicking like a malicious URL, um, which gives the threat actor access for remote code execution. And the vulnerability in this case is CVE 2023 2533, which yeah targets the admins, and over like 1,100 servers belonging to Papercut are like kind of exposed online. And while not all of them are vulnerable to the specific exploit, like many of them are in this case. And so like the CISA, they're mandating F- um federal civilian executive branch agencies in America to like kind of patch this up and everything. So it's like kind of strange. It's kind of strange to hear about this with me because like it's a threat with high severity within like government affiliated organizations like this, but also like a lot of I see a lot of people like in my job like printing like very like important documents and such. And yeah, it's kind of something to like think about when you like use services like this, and a vulnerability like this is pretty bad for paper cut. And we can move on to the next presentation.
All right. All right, so this is my presentation here. Just gonna make sure everything is set up. Hopefully you guys have been able to hear the stream properly. But yes, so this is something that I found very recently. I've been finding a lot of tools online. Oh, I forgot to introduce myself. My name is John Chrono, fourth year cybersecurity student. I'm supposed to graduate in August, but I have to take some other classes, so I'll be on campus with you guys in the fall, and I'll graduate in December. But very exciting time for me. But I found this really cool. Actually, I found like multiple versions of this, but this is one of the best ones I found. It's a AI-powered vulnerability scanner, and it basically, well, for now, only Hunter works on Python specifically only, but it works with large language models, and it basically takes static code like client code or server code and tries to remotely exploit or tries to find vulnerabilities that are remotely exploitable, but it specifically works for Python code bases. So yeah, a lot of new AI these days has been trying to combine AI with vulnerability detection, or AI with, drawing, or AI with, you name it. They try to they try to put those two together. So we're trying to constantly looking for these tools that would help identify more vulnerabilities before malicious actors do. Right. So we're trying to find them in development code or production code or on GitHub or in a local repository before it gets to the end user. So I found this a couple days ago or a day ago, and it basically, like I said multiple times, it only runs on Python code. It discovers 0 days in repositories, and it goes beyond traditional static analysis. If you look on the right side here, there's an image for the architecture. It basically takes a single repository, it goes through the application, and it checks for a bunch of different vulnerabilities, which I will go in slight detail just quickly before near the end. But it basically goes through those analysis tools, does another secondary analysis where the LLM will request more code, put that code into context, request more code, put that code into context, and as it gets more and more detail and more information about the project and the software and maybe the vulnerabilities that it has, it'll use chain of thought, which is reasoning. It'll analyze the code chain. It'll create an actual POC, and it'll even give you a confidence score of how likely this is to succeed in the real world, which is very, very cool. And I was thinking about it, how we can use it practically, especially with someone who's involved in ISSessions like you or myself. And I was thinking that, if you can use this in certain ways, like for Python repositories, for example, imagine you have a repository that has some vulnerability in it, and you use this tool to find the vulnerability. Then you find out how it works, and you reverse engineer it, and you make your own challenge for the CTF. That would be super cool. Something you can just learn that way, Maybe you can take it and instead of making just like textbook examples, you can actually make, challenges on real vulnerabilities, which I think is super cool. And then finally, I think we're just going to go over, I already talked about these, but we'll just go over the vulnerability types that it quickly that it goes over. So it targets RCE, which is remote code execution. It targets cross-site scripting. It targets SQL injection. It targets server-side request forgery. It targets local file inclusion. It targets insecure direct object reference and arbitrary file overwrite. So most of these you probably should know. RC is just execute arbitrary code on a target system from a remote location. Client-side scripting is where malicious scripts are injected into web pages that can be viewed by other users and potentially allow them the attackers to bypass controls and steal cookies, stuff like that. SQL injection, it exploits security vulnerabilities by injecting malicious SQL statements. You can dump databases, you can exfiltrate data, you can delete tables, pretty much whatever you want, really, if the vulnerability is broken enough. Server-side request forgery, if I remember correctly, this one is allows an attacker to induce the server-side server to make requests to an unintended location. So like some type of internal network port scanning or access internal services that you shouldn't be able to. And the LFI and IDOR, I looked up these earlier today because I had never heard of them, but they're actually quite interesting. So LFI is a vulnerability that allows attackers to include files on a server through a web browser, which can lead to RCE or information disclosure. And then IDOR, which is insecure direct object reference, is a security flaw that occurs when an application provides direct access to objects based on user input, which could allow you to bypass authorization and basically access stuff that you shouldn't be able to as a basic user. And then finally, arbitrary file overwrite is just a security flaw that would enable an attacker to overwrite arbitrary files on a system, which could lead to privilege escalation. So the fact that all of these vulnerability types are being detected by VulnHunter, I think is super cool. And we're just getting started. The fact that this is only for Python, like, it's going to be insane. Give it a couple months, give it a year, whatever. We're going to get a lot more tools that are in this type of area. So yeah, that's pretty much it from me. I think we have a break, if I'm not mistaken. And we're about to find out, so let's see. Yeah, break. So we have a break. I don't know if somebody wants to speak over this before we go on break.
Yeah, sure. Yeah, we're gonna take a short break. I'm gonna post the Google form in our stream questions, and yeah, the CCR will be on the slide, and we'll be back shortly.
We'll be back at 7:35. It's like 10 minutes from now. Oops.
All right, everyone, welcome back from the break. Our middle segment will be presented by Jamie, who is ISSessions' first ever competition director, where he is bringing new exciting ideas to the club daily. He's a seasoned member of the cybersecurity community with experience across 10 years and is currently interning with Mandiant, part of Google Cloud, as a security consultant. The floor is yours, Jamie.
Thanks. All right. Yep. Here. Okay. I'm sharing my screen. Are we good to go? Screen-wise?
Just give me 1 second here.
Just let me know when.
Uh, Okay, we should be good for both YouTube and Discord.
Cool. All right. Welcome to Evil LOL. The meaning will become more apparent as we go through it. But yeah, welcome to my talk. We're going to be talking primarily about what what LOL means in a security context and how we kind of deal with that in the forensics area. Just to give you a quick recap on who I am and why you should bother listening to anything I have to say. My name is Jamie, and I catch bad guys. I started my career way back in 2014 during a high school presentation from a software startup. I uploaded a meme to the presenter's locally hosted web server. The days of no HTTPS were fantastic, and it was hilarious. Did a challenge, and all of a sudden, I was writing web security software in JavaScript, and it makes me sick thinking of it now, but that's what I was doing. After that, I worked a few jobs, some in tech, some not, until 2021, when I, a glutton for pain, joined another startup, an MSP turned MSSP, where I got to architect, install, and maintain some pretty cool big IT systems. We can talk about that later. These days, I'm interning at Mandiant, now part of Google Cloud, doing digital forensics and incident response, which is going to be the main topic of today. Keep in mind that today's presentation is not representing Mandiant in any way. I am personally volunteering my own time to talk about something I enjoy with people I cherish. Okay, Worst part is over. Let's get going. Digital forensics and incident response, lovingly known as DFIR or DFIR or DFIR. There's a lot of different ways to look at it. And very simply put, we are the seekers of the truth in a world of uncertainty. We are the last people anybody wants to call. If we're getting called for something, it's because something bad has happened. We don't have like a cool like detection job or like a strategic consulting. We are the people you call. We're the 911. So that's what we do. And you'll notice that DFIR is split up into two kind of paradigms of digital forensics and incident response. And especially these days, these are actually two separate domains that work together, but they happen concurrently. So while we're responding to an incident that happens, we're also conducting forensics, trying to build the story. And we're going to talk more about that today. And the incident response is more the remediation side, which we're not going to delve into too much just for time today. But we'll cover some stuff on it. So if you have any questions, just feel free to post in chat. I'll do my best to keep up with you guys, and we'll kind of go from there. So the topic of today, evil LOL. What does that mean? Well, an LOL is just living off the land, and we'll delve into what that means. But in order to understand laughing out loud, just kidding. In order to understand LOLs, we gotta kind of talk about why we even distinguish this in a category, and we'll talk about this beautiful progression that happened. Back in the day, with traditional malware, it's kind of what we all think about, right? You have malware.exe, you have I am not a virus.vbs. This was very simply you got a file onto someone's computer, you ran it, and it did a bunch of bad stuff, right? This is the classic, like when we think of movies or um, your aunt or uncle calls you and it's like, I downloaded a virus. This is what we're thinking about. Now, these were great back in the day because there were no detections, antivirus sucked, and people didn't know any better. They would download anything if you told them there was an incentive involved. Luckily, we've moved on from that, and this traditional malware attack trajectory is pretty much gone. It's very easily quarantined by AV and EDR because now when a file hits a system, we're collecting the hash of that file. We're doing some pre-execution inspection. Like, we've got this problem pretty figured out. And on top of that, it also produces what we would call high value on disk artifacts, which basically means it does a bunch of noisy stuff that's super easy to find and super easy to create evidence from, which is not what you want when you're an attacker. You want to do everything super stealth. Nobody knows what's going on. Don't traditional malware, not the way to go. So then threat actors started getting a little bit smarter. They started realizing, okay, as much as we're the best programmers and we love doing this, we probably should start moving away from this. And primarily what drove the living off the land paradigm was digital signatures. It became a point where if your exe wasn't signed, it was very difficult to execute it, right? Like a pop-up shows up, enterprise environments, they just don't run. So it was very difficult to just go get commodity malware that wasn't signed and have it run. So it was actually an adaptation to a problem that they needed to solve. So then they figured out that, hey, Windows has a bunch of built-in stuff that we can use to replicate what our custom malware was doing, what our commodity malware was doing. And guess what? It's incredibly difficult to quarantine, has a digital signature, and it's already on the system we're attacking. Like, it's kind of the best of all worlds, really. The only thing that kind of sucks about it is now you can't just write an awesome program to do all your nasty stuff. You have to have some knowledge about the Windows operating system, and you have to know the evasions, and you have to understand how, if you're doing PowerShell, how that works. If you're doing a CLR injection, and we'll talk about that later. You have to have a little bit of know-how of how this works. But if you have the know-how, like you can run stuff, and you can very easily bypass quarantining detection. However, we do have ways of detecting it in EDR. The issue is, if I'm using something that's built into Windows, can you guys kind of foresee the problem you're going to run into there, right? If I run a utility that's built into Windows, right, and I run it and maybe I add some bad stuff to it, but I just run that program, I don't want the EDR necessarily to quarantine. I don't necessarily want it to stop it. I mean, great, log it. That's fantastic. But we'll see later in the presentation that like it doesn't take very much to do something nasty with it. So great, you can log it, but if we're not stopping it before it happens, well, that just means that the attackers can do what they want and we have to cry about it later. So that's the difficulty that LOLs bring up. And we're going to talk about how we as defenders have shifted how we do forensics and whatnot. But I also want to talk about this other concept that's actually a Mandiant uh, concept that was written about probably like 2018 now, and it's still being used today. And that's the bring your own land. So when we're talking about land, right, we're talking about tools and we're talking about software infrastructure, let's call it, right? Living off the land insinuates that we're just taking things that are already there, right, tools that are existing, and we're just kind of using them for evil instead, right? Bring your own land is actually, technologically speaking, a very interesting concept. Where now we're actually getting the pros from both traditional malware and LOLs because we can actually still write our custom software that's fast and it's doing exactly what we want it to do. And then we're using something like C Sharp in the C Sharp compiler to compile that code on the system. So not only do I get the full customizability, I can't. It's never going to get quarantined because that C Sharp compiler is absolutely essential for .NET to work. It's digitally signed, and it produces no artifacts. And I'll show you a really great diagram that will show you why it doesn't produce any artifacts, right? So that's kind of the trajectory of where malware and where attacks have kind of gone and how they're executing all this bad stuff. And as defenders, we've had to figure out how to deal with it. Okay, you've heard me say the word artifact a few times now, and you're probably wondering, like, what the hell are you talking about, James? Like, logs? The answer is yes, and it's also no. So logs absolutely are artifacts. But the most simplest way I can explain to you what an artifact is, and I can promise you that different analysts and different investigators will have different definitions. Artifacts are simply remnants of a system operation, right? So something happens on a system, and anything that is a product of that besides the intended, you know, operation that was done, right? Did it write a file? Did it make a network call? Did it write or change a registry key value pair? Right? If there's a cause, an artifact is one of the effects. And oftentimes, when doing DFIR, the artifacts being used have nothing to do with security. Only in recent years has Microsoft finally clued in and been like, hey, we should give analysts some more tools. But traditionally, what these artifacts that we're using are actually just feature enhancement or just standard components of an operating system. And that's kind of what I think is so cool about it is that as an investigator, we recognize that alone these artifacts probably don't mean a whole lot. But a seasoned investigator is going to know where to look for these and how to correlate them to start creating what we call a timeline. And that's the golden ticket, man. That's what people want is what is the timeline of events? How did this happen? What did they do? What happened at the end? Are they still in my system? Right? They have all these questions and we have to figure out the answer. So the structure of what we're going to do right now is I'm going to go through some primary categories of artifacts and kind of give you the cliff notes on some of the major ones. And then at the end, I've kind of picked like my top 8 for all you MySpace folks back in the day. We're going to go over sort of my favorite artifacts and sort of methods that attackers employ. So first, we're going to start off with login and logon artifacts. Can anybody tell me what the difference between a login and a logon is? I know this is like an old thing. If anyone wants to throw an answer up in chat, it would be really appreciated. I'll go through this, and at the end, we'll go over it. But anyways, login, logon artifacts. These are, I'm going to just say it, these are probably the most important artifacts. What you probably know is that any process that is executed, any file that is written, pretty much anything done on a system has to get associated with the user token. At some level, whether it's root or it's administrator, almost everything that's being done is associated with the user token, right? Or a session token. We recognize this. So if we can prove a logon definitively, right? We know that somebody logged on. That is an excellent first step in creating a timeline. And that's oftentimes the first step that we do to making it. So to kind of go through this list here, so 46xx logs are security logs, and these are incredibly high value. I highly recommend there's so many of them. That's why I put variables for the last couple digits there. These are beautiful. These are really clear logons, logoffs, RDP logons, RDP logoffs. These are going to tell you so much about who's interacting with logging onto the system and then who's also accessing objects. These are awesome. But these can also go cleared. So while they're super high value, they're also one of the first things an attacker will get rid of. Some of these other ones, like the SAM, stores the last logon and the logon count. And the SAM is actually just a hive, which is great. So it's a little more difficult to get access to as an attacker, especially if you don't have admin privileges. It's very difficult to get access to the SAM. So the SAM will tell us, again, the last logon, how many times they logged on. That's a great point of reference for you. Anti-user, user class, .dat. They are loaded every time a user logs onto a system. So they're user specific. However, they're also unloaded when they log off. However, we can track that they were loaded, right? And that will indicate potentially a logon. Logon script execution also indicate logon. So if we know in a system that the client has scripts that they run on logons, we can look for execution artifacts of those to prove a logon if, for instance, the security logs were deleted. And UAL, this is a great one. This is a newer one that's specific to Windows servers. It provides excellent insight into what roles are being accessed, right? So within Active Directory, we have different roles and different user groups, security groups. This will tell you all of that with a first seen and a last access timestamp. However, it does not store individual logon events, because if you think of like a primary DC in a large environment, that log would honestly probably be like unusable, and you'd have to roll it so often it would be useless. So they aggregate it. I believe it's by the day. Could be wrong on that, but they aggregate the results and give you a count. So it's not going to give you like a beautiful Gantt session chart, but it'll at least tell you that the logon happened. So these are kind of your starting point. These would be the first things I would be looking for in an investigation. Is let's just prove that they logged on to something, right? So great. Okay, so let's say they've logged onto the system. We need to go to the next stage of our analysis. Well, what's the first thing an attacker wants to do, right? They want that foothold, that persistence. That is the hardest part for an attacker, right? Is making sure they can stay in that system once they've compromised it, because they worked really hard to compromise the system. And you'll see, especially in Windows, there is a ton of ways to get persistence, and they're all sneaky, and these are all built-ins. So these are all LOLs. This is not malware that's running constantly. This is not traditionally what a beacon is. This is just built into Windows. These are all different mechanisms within Windows to have something happen at a fixed schedule, and especially now with WMI and schedule tasks, you can have it trigger on actions, which is even sneakier, because I can't just look for, hey, what happened, 15 seconds after a log on. It might be they might select when the person opens Chrome, right? And this is where this can get really tricky for persistence. One of my favorite artifacts to hunt for are persistence. And I also want to just give you guys a quick resource. I meant to do this at the beginning. Just going to post the link in the chat on Discord. This is a wonderful website that's actually still updated today. If you have kind of like deeper questions about Artifact, I highly recommend just do a quick look up on here first. And if it still doesn't make sense after, then definitely feel free to give me a question. But some of these artifacts are quite complicated. So if there's something where you're like, I don't understand what it's doing, take a quick peek at the link there. And if it's still not making sense, then absolutely ask me. I would love questions. Okay, so persistence, great. So we talked about WMI. What's nasty about WMI is WMI is broken up into three parts. Okay, so WMI is built up from what's called a filter, which is a trigger, a consumer, which is an action, and then a binding, which is connecting filters to consumers. So remember from databasing, or you can just start thinking about permutations of this. You can have a ton of combinations of trigger to action or filter to consumer bindings from a single WMI event. So attackers can get super nasty with this, and they can have a single filter connect to a ton of actions. And then guess what? Those actions can schedule jobs. So you can have a WMI event subscription that's job is to make more jobs. And it gets, yeah, exactly. I don't even know how to explain that. Active setup is kind of a weird one. It's honestly it's effective because it's super uncommon and it's built in. But active setup was an old enterprise feature that allowed you to have things set up when like an image is being built. I believe was the original intent of that. And it's nasty because it's you don't look for it, and it stores nothing in common areas like run keys, schedule tasks, and services, which is very common and well known. Active setup is kind of like another little door they can hide things in. Even if you catch everything else, you can find stuff in here. Shell folders, we know what these are. These are shell folders that are run on execution. They're very similar to startup folders, but shells can store more complicated objects versus startup. And my favorite one that I've encountered is DLL hijacking or redirects. What's super nasty about these is the attacker can create or modify an existing DLL, right? And we know that DLL are application extensions, so you can attach them to existing executables. And let's say in this instance, legitimate executables. So like every time a legitimate executable runs, we can run this nasty DLL. And guess what? Things run every time a system is operating. So you don't have to use a traditional persistence mechanism. You can just use a program that runs all the time. Or if you know that the user like opens Outlook every day, you can attach a DLL to that and have that run. And the only way I'm ever going to be able to detect that is if I do process inspection in memory, which is not great. And we're going to talk about that later. So, okay, so we've proven that they logged on. Maybe we prove that there was persistence, maybe not. Okay. The next kind of category we want to jump into is execution, right? Because at the end of the day, an attacker needs to execute a payload of some kind. And like a payload, that sounds so fancy and so evil, but like a payload could be a text editor, right? I want to edit a file. I want to just open a file, copy the stuff out of it, and exfil, right? Execution and payload, like it doesn't have to be this grand scheme. It doesn't have to be this super complicated piece of software. Like they just need to execute something. So we have a few different ways that we deal with execution. The activities cache is really cool. This is a new artifact that came in with Windows 10, and it was built because of the Windows Timeline feature, and it's becoming more popular. The only reason it's not super popular is because it's only on certain versions of Windows and up, which we still encounter a lot of older versions of. But I think as it gets more adopted, it'll get more popular. You'll see some of the other compatibility caches here, and I missed a, oh yeah, I missed a slash there, but mcache is separate from appcompat, sorry about that. And you'll notice a little asterisk on the end. Anytime I put an asterisk, that means there's a caveat. So these cache artifacts can prove execution. They often, I would say most of the time when these artifacts happen, it's because a program is run, but not always. And this is an important distinction because remember we talked about earlier, like we need to know what we're talking about, right? So an attacker might run a payload, but it might not execute, right? But the amcache, appcompat, and shimcache will still have an entry. Because what these do is they just check for compatibility with software, right? So if I compile a piece of software, and let's say I compiled it for Windows 10 build, blah, 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 right? But whatever, the system I'm on is maybe a later build of Windows 10, maybe it's Windows 11. The amcache, appcompat, and shimcache, depending on how that system is set up, are going to try to create some compatibility layers with those API, but they might fail. So we can't always say that these are proof of execution, but they're at least really good at taking an inventory of things that may have been executed. I hope that delineation makes sense. Uh, Next up, personal favorite of mine, System Resource Usage Monitor, the SRUM, as we love to say. It's great. This is literally how Task Manager, or sorry, what Task Manager is built off of. The only drawback is that the timestamp that's associated with the process usage is associated with the time that the record is written. So basically, the SRUM is a database, and the timestamp is written basically when the record is written, which is once per hour. So you don't get super precise timestamps from this, but it's still a great resource. And we might use this when we think, hey, like, were they running an encryptor? Were they running uh, some CPU intensive process? We'll be able to see this in the SRUM. We'll be able to go, okay, the system was idle for 4 hours, and then like in the middle of it, there's like a gigantic spike. Like what happened, right? Excellent, excellent artifact that I like to make use. Link files, these are fun. Really simple. Every time you double click on something in Windows, right? So you have whatever executable, you double click it, link file is created, and it tracks the path of that file. Also, we can have permanent link files, right? So when you make shortcuts, it can happen. But really, this is great because this shows that something was clicked on. And if something was clicked on, what does that actually mean? That means that there was an interactive session, right? So that means that they actually logged on, got a full session, and they're playing around in the desktop. And this is a fantastic artifact. I can see them click on folders. I can see them click on executables. This is super useful. You can, like, when you see these in your your forensic software, like you can actually see the path they took while enumerating on a machine. They may have been clicking on things, going through folders, trying to find what they wanted, or just being exploratory. And good old prefetch. Prefetch is a classic strong execution artifact. I believe, yeah, this was a performance. Yeah, this was a performance edition, and the idea was is that they want to store some information about applications so that they start faster, right? So a prefetch file is created whenever a program is executed, right? And it has to actually execute, which is why this is so important. This means that the program successfully executed, the prefetch file was created, and it stores some really great information about that file. So again, what's important about execution artifacts is oftentimes an attacker will deploy the payload, run it, do all sorts of bad stuff with it, but then they delete it. So then we can't prove, like we can't say, oh, like I found the file, here it is. We have to prove the execution with these artifacts. So great. So now we have some execution artifacts, but now maybe we want to start looking at what was the attacker doing, right? Like kind of what were they enumerating? Like what were they looking for? That's where we get interaction artifacts, and the reason we separate these two is because interactions are often associated with like enumeration, right? This might be the attacker exploring the environment, exploring the endpoint, trying to figure out what's on the system. Are there SMB shares open? Like what does this person have available? And they might literally just RDP in or whatever, pick your remote desktop software that you want, and just start playing around and start trying to figure out what this person has access to, what they can see. And these are all UI artifacts. And you'll notice there's some overlap, right? Prefetch shows up again, link file shows up again. And that's kind of cool, is that there's some artifacts that just give us so much good information that they show up in two categories. But really quickly, you might be thinking, what the hell's a shell bag? Shell bags effectively keep track of folder settings. So when you go into a folder and you pick a different view, or you say, I want to show file extensions, right? You see that in your Windows. That's executed with a shell bag, which is an entry in the registry. What this also stores is where users have navigated within a directory. So if a user hovers their mouse over a folder, a shell bag is created. If they click into it, a shell bag is created. So this is awesome for and I see this all the time with SMB, right? They'll open up a share folder and they'll just hover over stuff to maybe see the comment or whatever, thinking they're being sneaky, right? They're like, oh, if I don't click on it, nothing bad will happen. Well, bad things happen for you, buddy. We get some stuff. So yeah, shell bags really great. This gives you probably the best visual of like following an attacker through what they're doing. Typed URL, exactly what it says. If you type a URL into Microsoft Explorer, right, so your file explorer in Windows, or into Edge, it shows up in typed URL. So this is great if an attacker is punching in an SMB share manually, or they're trying to do some manual enumeration. If they happen to go and look up websites, you'll often see attackers looking up, and I've actually seen this, attackers looking up like file share websites. Like they'll be like mega upload pricing or like some weird European upload pricing. Like they'll literally look up their exfil while they're doing an attack. And I've actually gotten some pretty good insights from that. So yeah, so really kind of a fun artifact to to see. Um, Next up, user assist. Oh yeah. So user assist. This is kind of a weird one. So user assist, what it's allowing you to do and what's allowing you to see is also execution of executables, execution of executables. But most importantly, this also will show you portable executables, which is really good. So user assist gives you some great insights into portable executable. Oh my goodness, artifacts and whatnot. And again, we will use some of these other artifacts and correlate across these. Sometimes you get high value artifacts, sometimes you don't. It's just kind of part of the whole game, unfortunately, is trying to figure out what's high value, what's important, and all that. Next, jump list. Okay, so we've all probably seen a jump list. Um, Imagine you're on Windows. Let's say you're in like Microsoft Word, right? And you hover over the little Word icon, and you get the list of recently viewed files. That's facilitated with a jump list, which is again just a list of recently opened files. Where this is often used in investigations is Explorer. So we can see, hey, like there's something in a jump list of like they went to this folder all the time, and we can be like, oh, okay, we should probably look into that folder and see what's in there. And sometimes it's a staging directory, sometimes it's a target. Really, really good. PowerShell logs. We're going to talk about a specific kind of PowerShell log a little bit later, but on newer versions of Windows, interactive PowerShell logs, or sorry, interactive PowerShell sessions are normally logged. So you click on PowerShell, start typing stuff in. That'll normally go to like your readlines file, and we'll talk a little bit more about a more advanced form of PowerShell logging. That's really cool. And oh, link items prefetch. We talked about these already. So again, these kind of fall in here because if we've proven that something was executed, then it's also been interacted with, right? It kind of makes sense. But I like to give them a second mention because they're worth it. They deserve it. So then, at this point in an investigation, you've probably proven the logon may or may not have found persistence. Just depends on the system. But let's say you did. You found the execution, which oftentimes you're finding from the persistence artifact, right? The persistence artifact, right? The attacker creates it, points it to their piece of malware or the bad thing that they want to happen. You find that in persistence, and then we go prove the execution of that. And then we might find some interaction if they were playing around. And then lastly, and I don't mean to like pick on networking, but Windows network logs, or let's just say endpoint network logs, are not great, right? The endpoint in the operating system is just associated with the process sockets for a network connection. It's not really concerned with where it's going. That's for networking gear, right? So that's where you'll see a lot of firewall logs, router logs, if they have a DNS server. God bless their heart if they have HTTPS inspection, because then we can actually read what the heck they're doing and what they're sending. But oftentimes, if we need network artifacts, we're generally turning to a network device. We're not going to spend too much time on the endpoint, because on top of that, like you might be thinking, well, hold on, Jamie, like don't we want to see like RDPs? Don't we want to see lateral movement? And it's like, okay, yes, absolutely correct. But if they're RDPing onto something or they're doing something like that, there's going to be a logon artifact. And the logon artifact is infinitely more valuable to me than the network artifact. The network artifact might point me in the right direction, but when we're doing artifact collection across 10,000 devices, I'm not following it sequentially. I'm just going to check for logons across all the devices and start creating my map that way. If I happen to correlate that with some kind of network, great. Network logs and network artifacts are super important, mostly for exfiltration. And we're going to talk a little bit more about that in detail in a second here. But honestly, if we're coming into an investigation and we need to know something about a network-based attack or network-based path, I'm turning to the network devices almost instantly. Okay, so we've gone through kind of the main categories of artifacts. You've gotten a general idea of what's going on. So we're going to jump to my highlights, my favorites. And these are my four favorites that I picked up for you. So first one is volume shadow copies. And then we have background intelligent transfer service, or BITS, as we more commonly call it. And then the .NET CLR. And this one is really cool. We'll talk about this in some detail. And then PowerShell script block logging, which we will talk about why that's different than the one I mentioned earlier. Okay, so I think I have these in order. Hoping I have these in order. So VSS, volume shadow copies. What the heck is VSS? VSS is a built-in Windows, basically a snapshot feature. So this, from a system administrator standpoint, what this allows me to do is I can pick disks or folders and have something called a shadow copy be created at a fixed interval. It might be every hour, it might be every day, twice a day, doesn't matter. But VSS is a super important aspect of system administration and managing a Windows environment. At a basic level, what this would allow you to do is if you had, say, a file share, and let's say someone was editing a document or a spreadsheet, and they totally destroyed it, blew it up, they could right-click, go shadow copy, or it might be versions now, and they could literally pick from a list of shadow copies and revert the file back to an old version. And this can be done for any file present on a system. And I very specifically mean any file because I'm going to explain to you what this piece of code is. So remember earlier when we were talking about LOLs and we're talking about, oh wow, like the kill chain is so good and like it doesn't take very much to do something bad. The code that you're looking at right now is more than enough to completely compromise an Active Directory environment. You might be asking, Jamie, how the hell are you going to compromise Active Directory in like 3 lines or 4 lines of code here? Well, the first one I think is quite obvious. We're creating a shadow copy of the C drive, right? Now, if this was a domain controller, which is a very popular target for attackers, uh, very important files live on the domain controller. And you can see in the following commands, that's our ntds.dit, our system hive, and our security hive. Well, ntds.dit is basically what we call the holy grail of an Active Directory-based attack. That stores all the information about your Active Directory users, passwords, roles, the whole bit. You get access to that file, you can recreate their Active Directory environment. Like this is the worst thing. And it's so bad, in fact, that lawyers will actually ask you about the dit, right? So if lawyers have figured out how bad this is, then you know it's bad. So just to put that out there. So what is this doing? Well, normally the ntds.det, the system hive and the security hive, they can't be copied. They can't be read from with normal utility. Like I can't run this command and copy them because they're in use by the system, right? They're in use, they're in memory, and I can't easily copy these with normal tools. However, volume shadow copy, by its nature, allows me to make copies of, remember, any file on a system. So I effectively make a copy of the files on the C drive, which include these files. I can now copy them from the shadow copy to wherever I want. In this case, C/temp. So you put it in C/temp, you have these three files, and I'll show you in the next slide how we get those files off of the system. But if you really wanted, you could pwn the Active Directory right here. You could put your Python script, pick your poison, pick your tool, crack all the passwords, and it's game over. Right? If they have weak passwords, I'm almost certain you'll get something. And this is a Windows built-in. These commands with no other kind of detection engineering will run. So if you get access to the domain controller and run this, it's done. Like you've compromised it. So VSS, again, awesome Windows utility, super useful. We need to keep an eye out for them. How do we keep an eye out for them? Well, we keep an eye out for manual executions of VSS admin. We keep an eye out for certain file names, certain paths of the shadow directory, right? Because oftentimes with the shadow copy, we're not oftentimes copying out like the three most important files on an Active Directory domain controller, right? So we have some detections for this, but again, how do we quarantine this? How do you like you can't stop shadow copy from running because we need backups, we need snapshots of files. So this presents a problem where like they can run this, do the deed, and it's done, right? So this is one of my favorite artifacts to hunt for. Is literally just looking for execution artifacts of VSS admin. We can look for logs, right? There are Windows event logs, and if they're not deleted, hopefully, we can find execution artifacts. So this is literally how to pwn Active Directory in 3 lines of code. On top of that, you might now be thinking, okay, attackers are better than this, right? Though, like they're gonna like get these files offline, right? You might be thinking, well, Jamie, we could block that, right? Like we could stop, SCP, we could block WinSCP, right? Like we could figure something out here. Well, we could, right? And there's also that great thing, right? The background intelligent transfer service, BITS. Well, BITS is also built in, and BITS is exactly how Windows Update works. It's how it basically allows you to do a network download or upload in the background, right? So it won't interfere with the general network calls that come out of a system. And this is great for Windows Update, right? I can hit update now and have it not crash my network connection, right? So like when I'm gaming, I can hit update and not have it kick me out of my game, right? Awesome service. Once again, this is a great feature. Like this is fantastic. But guess what? Attackers also know that it's fantastic. So once I've dumped these 3 really important files to this temp folder, or maybe even to the desktop if I'm being extra cheeky, I can then use this tool, which again will not get stopped. This with no detections will just run, right? So I don't need a custom malware, I don't need a custom C2 uploader, I don't need any of that. I just run this. This is just like free network transfer. Like it's fantastic. And in this case, I'm showing you some exfiltration, right? I'm showing you we take our file, we upload it to our little HTTP server. What is that? Python-m http.server80 or whatever. Like you run that, you put your address in, boom, done. You've got the files. This also works the other way. I can download payloads with bits and not have it be detected. Okay, on the note of detection, JB, how do we stop this? This is horrible, right? Well, what we generally try to do is we will try to obviously do like domain lookups, manual executions of the bit service. We'll do domain lookups. We'll do file name lookups as well. Like we will literally have like regex, case insensitive for like these files. So we can we can try to build these detections, but attackers are smart. Like they're not going to put evil.com and they're not going to keep it as NTDS. They're gonna do like Office templates 69.pl slash Excel slash don't worry about it. Like like they figure out ways around it. So this is actually quite a difficult problem to solve. But so we've figured out, okay, you can copy all these files with a built-in utility, a lol. You can get it out with the lol, right? So now you might be thinking, okay, Jamie, let's say I get absolutely perfect detections. I've defeated the attackers from using VSS and from using bits, right? You are the pinnacle of cybersecurity, okay? Well, there's this great thing called .NET. And if you don't know what .NET is, do a quick Google on it. If you're on Windows, look in your computer for .NET. It is everywhere. I believe, if I'm not mistaken, .NET is the main framework for building um, applications on Windows. So you can build client and server applications, and it's built from C Sharp, which was Microsoft stealing Java, right? So this has to be in Windows because most of your applications and stuff run on .NET. Okay, so we can't just get rid of this. We have to keep this in. And I'm gonna explain to you what this diagram is showing. But the first thing I want to ask you is I've kind of given you a hint as to like this is bad. But if you look at this, right, you just look at this. Forget Procmon. That was obviously done for the demonstration. Like pretend Procmon isn't there. Focus on the PowerShell. Okay. I want you to like just looking at this. Like, does this look bad? Right? Or if you look at this with no prompt, you would probably just be like, okay, you called PowerShell that spawned a PowerShell that ran some exe. Right? Like that's what that looks like. No? Does anyone disagree? Like, does this look bad when you read it? No, right? Like it looks pretty bad. 100%. Why does it look pretty bad there, display? Like what about that sets you off? What triggers you about this this picture? Yeah, John, absolutely. Okay, so just to go back to display process. Okay, because I don't know what rundl32.exe. That's not base shell. Yeah, service. That's a really good insight from this. And that's fine. So we kind of know this from just dealing with computers, that this is important. But we also maybe don't know, but like rundll is a legitimate file name. And if you've worked on Windows, um, you'll know, like you've seen rundll. So the file names alone don't look that suspicious, right? If you have a little more like know-how of what's going on. But rundl is effectively, I'm trying to think of the best way to explain this. It's kind of, think of it like a wrapper for calling DLL functions. It's kind of the way I think about it. But it is a legitimate file. You can find it in sys32. You can find it in sysfile64. Like this is legit. Like this as it appears is fine. Service, you were definitely on to something a little more. Yes. Okay. So service caught the one hint that you can see is that the paths here are wrong, right? But again, Yes. Okay. Perfect. So yeah. So it's not completely unheard of to see like syswow call sys32. It does happen. The more complicated part of this question is we know that sys32 and syswow64 are legitimate, right? What the attacker did here was they just made it lowercase. So it's actually, this sounds silly, but it's actually difficult to create a search for that because we can't just assume that everything in here is bad. Things get renamed and whatnot. So what's actually going on here, and it's kind of strange, but we're gonna look at the PowerShell 804 is just a normal PowerShell execution. Okay, so this is just whatever. They started a PowerShell, they triggered it in the command. It doesn't matter. This is normal. The 2792, right? PowerShell 2792 looks fine, but this is actually the beacon software. So this is the beacon for the C2, and then the run DLL 32, the 27 process 2708, is actually loading some malicious C# code. So on the surface, doing a quick kind of overview of this, you actually might see something like this. Like if you write a PowerShell that calls another PowerShell that then requires the DLL to be loaded, like this is actually something you might see um, in execution. But yes, absolutely, the paths would be the first thing you'd want to pay attention to. But what's absolutely nasty about this is, as the attacker, I can run whatever code I want here. And what this is going to show up on the disk in artifacts is just that the PowerShell 804 ran. We had an advantage here because we caught this live in memory, right? But as an artifact, all I'm going to see is that there was a PowerShell execution, and there was potentially a call to create remote thread, which is a WinAPI function. And there's also load image, if I have that correct. I think it's, yes. So we have create remote thread and load image, which are WinAPI functions that are totally legit. The entire chain of this is legitimate. Like there's nothing strange about PowerShell calling this to calling that to calling this. We can't just say no more load image. We can't just say no more create remote thread. Like that's how the software works. We can't get rid of that. What we do have to check for, like Service pointed out, is we have to look for paths, and we have to actually do inspection. So that's the key thing here. So when we're compiling things live on the system, we actually need to inspect that. And there's a few different ways that we can do that. There's actually ways you can stop live C# inject or compilation on the system. But what is super nasty about this is they ran a normal instance of PowerShell, did a beacon from this PowerShell, which is probably not going to show up anywhere, that pulled this malware and ran it. Actually, pulled the source code, encoded, compiled it, ran it, and all that's going to show up is that the parent process started, spawned another process, spawned another process. I have no way of actually seeing what this did other than it happened. Again, we know that it's bad because we can look at the paths, right? And we can also kind of make an inference that it's bad. But the truth of the matter is I can't look at the PowerShell log and tell you what happened. All I can tell you is that that second PowerShell looks like a beacon software, but again, we can obfuscate that. At the end of the day, the issue here is that the main artifact is just PowerShell execution. So this becomes really nasty. What EDR is doing to solve this is what Service pointed out. We're looking at paths. Sometimes we're collecting the hashes of things, but we all know like you can change a few things, and hashes are kind of pointless at that point. What Windows is starting to implement is CL compilation inspection, which is actually inspecting the code that's getting compiled in C#, which is not something that it currently. So this is pretty nasty. So this allows you to get the full flexibility of traditional malware with the benefit of lolbins by using PowerShell and C# compilation, which are digitally signed legitimate processes. You're also completely hiding the intent of what you're doing uh, via this process migration technique. So this is a pretty nasty thing to encounter. It's quite rare, but it does happen. So that's kind of like the evolution of where we've seen malware get to is they're literally just dumping like a dropper script, pulling the source code that's obfuscated, compiling it on the system, even sometimes decrypting it. So sometimes they download encrypted software, decrypt it on the system, compile it, run it, it's gone. There's no artifact other than maybe if the EDR caught it, right? But if the EDR doesn't catch it, this doesn't exist. All you're seeing is some PowerShell remote threads being created and a C# code getting compiled. So hopefully the EDRs rather get better at detecting this, and they are, but this is still a nasty thing that you will see out in the wild. And last but not least, something that I think is really important, and this is incredibly common. So the most basic form of lol is just PowerShell, right? How do you use PowerShell to just abuse a system? And this is kind of the way. So without script block logging, again, all we see in the logs is just a bunch of PowerShell executions. In this case, this is remote, but sometimes you'll see just local PowerShell execution. You might see remote. You might see create remote thread, depending on how they have sysmon set up, but not always. But at the end of the day, you're not actually going to get this. You're not actually going to get the code. You're just going to get like the execution event and the remote thread event. Well, how does that help? It doesn't. So you have to actually enable the script block logging. It's not on by default. But if you enable this, and this was a cool article I actually found today, people have written some really cool scripts to reconstruct PowerShell. So what they'll do is they'll write a PowerShell script, basically split it into a bunch of different files, and then download it in random orders, and then reassemble it on the system. And it totally throws off your logs because it's not it. This will give you a number, right? This will say 97 of 121, but you don't actually know if that's the sequential order of the code. They'll actually rebuild it with a small piece of code, and it totally screws you up. The script blocking totally beats this because we get the ID, and with the ID we can just permute over this and reconstruct the code, which is pretty neat. So super important. Turn this on. This will help with the majority of lolbin attacks, but if it's not turned on, you're simply going to get PowerShell execution, maybe some remote thread stuff. But between PowerShell script logging and EDR, we've got a pretty good grasp on what's going on, but we are still trying to figure out how to deal with full in-memory payloads. It's a difficult problem to solve. And yeah, that's it. Question time. If people have questions or comments, thoughts, opinions. There was quite a bit of content there. If you have questions or whatnot, don't be shy to ask. Um, Thanks, Jamal. Yeah. Um, there's definitely a lot to forensics. Um, I think as a field we've definitely got some good tricks up our sleeves. But tactics evolve, and that's why purple teaming is so important, right? And I think some of the cool lol stuff that I've seen where I love, I don't know why, there's something really clever about using something that's already on a system and just kind of changing it for your evil deeds. There's something really clever about that. And yeah, it's really fun to kind of hunt these down and see how they retrofit these in. But one of the issues we face with the fully in memory attacks is very difficult to get artifacts from that, right? Being in memory. Okay, question from Amal. Okay, so question from Amal. How often do you see companies that don't have detections surrounding the dumping of NTDS? Yeah, great question. So we kind of have to break your question down. So to have detections, okay, so when we're talking about a detection, we're probably talking about EDR, right? We're talking about something that's looking at the process in memory and trying to figure out what it's doing. Because a file-based detection for this is pretty easy to defeat because they're never going to use a plain text name. They're going to use probably some encoded name. Yeah, custom alerts, exactly. So like again, like traditional like AV and traditional like, or not EDR, but like traditional AV, traditional like on disk like validation, it, you just defeat that by encoding names, right? Just random encodings. It means doesn't matter to the attacker because they know what it was encoded to or what. So we have to try to stop these things in memory. And if we go back to the VSS slide, right? Like this was just for demonstration purposes, but any even EDR, like it's not necessarily going to stop this VSS command, right? Because this might be a legitimate shadow copy job. I mean, we can put alerts in for it, which is great. Like you might get an alert, and if you have a SIM and you have a SOC and you have people respond, you might be able to stop it pretty quickly. But if you're just deploying the EDR and hoping it's going to quarantine it and actually like stop it in its track, probably not. And that's part of the problem. So yeah, most companies that have a SIM or a SOC implemented will probably have people responding to that alert instantaneously of like, okay, why is someone doing this? But otherwise, no. I mean, otherwise, like the EDR is not going to say that that's necessarily bad. And again, this copy code is like just super obvious, but there are some better red teaming tools that do this, by maybe just doing like WMIC encoded command, right, to bypass EDR and stuff. So there's definitely evasion techniques for it, but no, I often most companies that I'm working with have EDR. They're looking for NTDS dumps. Yeah. So the short answer is not very often, but the second part of that answer is there's still ways to get around it. So yeah, no, great question though, great question. But yeah, just keep in mind that the difficulty with the lull bin based attack is just we don't always know that it's bad. We can't stop it in its track. Like with traditional malware, we just stop it. Right? We just quarantine it. Nothing bad happens. You stop and quarantine a VSS job, like that might cause data destruction. Right? Like, and this becomes the challenge. Yeah, awesome. Any other questions, thoughts? Do we want to see like a workshop on some forensics? Collecting artifacts and going through it. Drop that in chat. We'll definitely consider it to develop that. I can give you a more technical dive into how to actually pull this kind of stuff off. But yeah, otherwise, thank you for your time and thanks for letting me talk about what I do every day.
Thanks a lot, Jamie. That was a very insightful presentation. Very interesting, and we all appreciated you taking the time to speak today. And I guess yeah, that concludes our ISSessions meeting for tonight. Once again, thank you all for joining. I hope you all enjoyed, and yeah, we'll see you at the next one.